Hey, thanks for joining the webinar. My name is Wesley David, and I'm a support engineer here at Compose. So let's ask the obvious question. What is MongoDB? I'm going to break this down word by word for you to see if I can make it a little bit simpler to understand. So first of all, you see JSON in the name, or in the description that I gave you. So what is JSON? It stands for JavaScript Object Notation. It's basically a really easy, human-readable way to represent data. The quickest, most thorough way that I can think of to get acquainted with JSON is actually to head over to json.org. It's a simple specification, and you can basically master it in about the time it takes to eat lunch. And it's basically just a means of expressing information using a very small handful of symbols. But MongoDB's version of JSON isn't 100% pure JSON. It's actually referred to as JSON-like in some of the documentation, or elsewhere it's referred to as extended JSON. If you want to find out more about that, you can go to docs.mongodb.com and search for MongoDB extended JSON. And so basically, in a nutshell, MongoDB has the ability to add objects like date objects or object IDs, which are unique identifiers for documents. But for the purposes of this discussion, we're not going to go into deep detail about extended JSON, but the information is out there if you'd like to take a look at it. The next word that I used to describe MongoDB is document. The word document is not actually used in the sense of, say, Microsoft Word documents or PDF documents, OpenOffice, whatever. It is referring to a valid unit of information in JSON. Now, as you can see, this is actually a valid document right here. It starts with the left curly brace. It ends with a right curly brace. I've got a field called _ID with a value of 1337. Then we have another field that's separated by a comma, which tells the JSON parser that we have two fields here. And then valid is assigned the value of true, and that is a valid JSON document. And the final word that I chose to use is the word database, because it's just a database like anything else. There's no magic, there's nothing too crazy about it. You're not going to have to call into question any prior experience you have with database engines. It's still a database. It still uses indexes, and then there's still kind of a fuzzy concept of tables. In MongoDB, it's called a collection. So coming down to some of the grittier things that I think you should know about MongoDB is that it accepts data from you using JSON or extended JSON, and it presents it back to you and your application as JSON. Behind the scenes, it's actually writing the data to disk in BSON format, and that stands for binary JSON. So what exactly is BSON? Well, if you want to find out more about it, I would recommend going to bsonspec.org. BSON is the reason that MongoDB's implementation of JSON is actually called extended JSON, because BSON itself supports more data types than JSON does. And instead of just leaving those, MongoDB decided to add extensions to JSON so that you could take advantage of those richer features of the underlying BSON. And then lastly, to describe MongoDB to you, I don't think we could go any further without mentioning replication and sharding. Probably heard a lot about it if you've heard anything about MongoDB. It's relatively easy to use replication, relatively easy to shard your data. You know, when your data gets to humongous proportions, that's actually pretty important. And by the way, I just used the word humongous, and that reminds me of a question that we get asked in Compose support, and that is, what exactly does MongoDB mean? That's kind of a funny name. So here's the secret. It's actually the English word humongous, and then you see the little substring Mongo in the middle of it. Get it? Humongous, Mongo. It's probably not that funny, but anyway, true story. That's where MongoDB gets its name. So you might be asking, as you've seen MongoDB become more and more popular, why is it so popular? I'm going to give you my reasoning as to why I think MongoDB is so popular. So first and foremost, it's easy to write software against it. I think that's a bold statement, but it's one that I think I can back up with some objective reasons, and we're actually gonna go down the list here. So first of all, like we found out, it's a JSON-like document store. Virtually every language has at least one well-developed JSON library, probably more than one actually, with different strengths and weaknesses compared to other libraries. And just about any language that you can think of actually has a driver for MongoDB these days. Many languages like Ruby or Node, they have several drivers, and then there's a huge community and ecosystem out there. So there's a lot of people that are willing to help you with your MongoDB issues. And then there's an ecosystem out there, just enormous, humongous, you might say, of open source projects, vendors that make add-ons and help your applications. Schema lists. This is actually really important. It's a pro and a con at the same time. So you don't have to really know the kinds of data or the shape of the data that you're going to put in the MongoDB database. As long as it's valid JSON, it'll accept any old document that you put in it. So MongoDB is actually great for just tossing up an application, and then you can just stick data into the database. It encourages rapid iteration. So it's a great general purpose database. And you have kind of distribution with replication and sharding kind of built in almost for free. It's really simple how to get data replicated and sharded. And then the next thing is you have a lot of good data types to choose from and indexing to choose from, because like I said, it's at its heart, it's still a database. It still has general database concepts. It's actually really simple to administer. The tools have a familiar syntax. It's basically JavaScript. Well, it is JavaScript. It's a JavaScript shell. So we've talked about what MongoDB is. It's a JSON-like document database. We've talked about why it's so popular, at least my opinions on why it's so popular. So let's mention briefly the topic of the tooling ecosystem, which is kind of a subset of why it's so popular. First would be MongoDB's own tooling. And chances are that if you've ever played with MongoDB, you have right now on your hard drive, you actually have the tools like MongoTop, Mongostat, MongoPerf, MongoReplay. There's actually quite a bit of tools that ship with MongoDB in its own package components, and you can get pretty far in the process of troubleshooting and performance tuning MongoDB with just what comes out of the box. You don't absolutely need a ton of fancy tooling. And if you want to learn more about that, you can go search MongoDB package components on MongoDB's documentation site. And then next we've got quite a bit of tools that you can run locally on a workstation to connect to MongoDB remotely. There's a lot out there, but two examples that I'm going to speak of are Mongostat and RoboMongo. But like I said, there's a lot of others out there. So you can head on over to your search engine of choice, and there's plenty to work with when you're looking for MongoDB user interfaces that you can download to your workstation. There's also tools that you can use remotely from your workstation. For example, humongous.io is a web-based interface for MongoDB. Now the user interface in this case is it's hosted on their servers, and then you pay a monthly fee to use it. But then there's also something called Mongo Client, which is, it's the same concept. It's a web-based user interface, and then it's open source. But there's plenty of other options out there, and that includes analytics tools. So, for example, if you search for MongoDB analytics tools, it brings back a ton of results. Some that come to my mind right now are like JSON Studio, Quasar, Slam Data, Tableau are just a few of the names that I'm personally familiar with hearing. ETL tools will help you get data in and out of MongoDB, and some names that I've heard of are like Kettle and Stream Sets, just to name a couple of them that I've heard. But of course, before I move on, I want to tell you that of course your mileage may vary. We don't support these tools, and even me mentioning them doesn't imply that they'll work with our platform. But and we don't have any partnerships with these companies or projects. All right, so enough about all that. Let's dive into Compose specifically for a little bit. And I'm going to show you how we do MongoDB at Compose, and then how you can get started with us for free, and then how you can interact with MongoDB deployment once you get it all rolling. First things first, let's get you set up on a free trial account at Compose. So if you head on over to compose.com and hit that green button that you see, 30-day free trial, unlimited deployments, that'll get you set up. Just a little bit of information from you, and you will have a free account. One of the questions that we get in support is, what exactly does free mean? So it's free for 30 days, basically in every way that you can possibly think of. You can have any number of deployments in any combination. So yes, you can go ahead and launch, let's say, 100 Postgres and Redis and Elasticsearch deployments, no problem there. deployments of any size, and you're never going to pay for anything that you do in those first 30 days. So does that mean that you can import hundreds of gigs across dozens of deployments and rack up a monthly bill that would otherwise be, let's say, tens of thousands of dollars? And the answer is yes, and people actually do that. And we're totally fine with that. In fact, we encourage it because we want to make sure that we're a good fit for you, and ultimately your happiness and your application's performance is our primary concern. So go ahead and kick the tires. Keep them for 20 days, 23 hours, and 59 minutes, and it will not at all be charged to your account. There is literally zero commitment. You can walk away, never talk to us again, although that would make us sad. Or you can keep them forever and there's no retroactive billing. The reason I bring that up is because I am in support, and I do hear a number of the questions that people commonly ask, and one of them is, hey, so if I let it go for 31 days, you're not going to reach back and charge me for what I use in the first 30 days, are you? And the answer is no. There's some shady billing out there on the internet, but Compose isn't one of those places. So with that out of the way, let's move on over to the Compose UI. I'm here in my trial account, and there's a lot of deployment types that Compose offers, but we're going to focus on MongoDB for this webinar. When you click on MongoDB, there's a couple things that you have to choose and think about before you deploy. You want to choose the name of your deployment here. Now be careful because this is immutable at Compose. Once you name deployment, you can't go back and rename it, so choose carefully. Then you can select your location. We support Amazon Software and Google in a wide variety of data centers. I'm going to choose Amazon. I'm going to choose US West 2 because I'm from Oregon. Go Ducks. SSL access is enabled by default. Please, you want to consult your driver for tips on how to connect with SSL because some drivers can be maybe a little bit quirky, but typically speaking, if you just follow documentation and maybe consult with the community a little bit, you'll be connecting to us over SSL in no time. Next up is your choice of storage engine. You can choose WiredTiger or not. If you don't choose WiredTiger, the default storage engine is mmap v1. Since I'm in support, I see the question, should I choose WiredTiger or not, come in quite a bit. And the standard answer that we have for that is, if you don't know that you need WiredTiger, then you probably don't need WiredTiger. That's a bit of an oversimplification perhaps, but if you're uncertain, just leave this checkbox unchecked and then have mmap v1 as your storage engine. In our experience, WiredTiger is great, but there's no slam dunk or out-of-the-box magical improvements that you bet you'll see unless you've explicitly developed your data in a way that will take advantage of WiredTiger. So if you haven't done a lot of thinking about WiredTiger, just leave that unchecked. Also note that WiredTiger is more expensive than mmap v1 at Compose, and we're going to talk a little bit more about that here in just a bit. Concerning the database version, we start you off with the latest stable version that we offer at Compose. And then the final decision you have to make is the initial deployment resources that are given to your deployment. You can ignore this if you want, but if you have a big ETL job or perhaps you're restoring a database, restoring a backup to Compose, you can pre-allocate space on this slider. It might make the import just a little bit faster, but generally speaking, you can ignore this if you want. So let's click Create Deployment and get this deployment started. This is going to take a few minutes, let's say about 5 minutes. While it's creating, let's flip over to a slide that talks about the architecture of MongoDB at Compose. We're going to work top down. The globe at the top is the internet at large, and then we have 2 MongoS nodes in blue. Those are the only things that are publicly exposed of your deployment. And then behind that, in this blue circle, is your data shard. It is on a protected network that's only accessible by the nodes in that shard. Only the MongoS nodes have access. This is a replica set in blue. Perhaps a little inaccurate because the config servers aren't, strictly speaking, considered part of the replica set, but the green, yellow, and black MongoD nodes that you see here would be considered part of the replica set. So how we do it at Compose is there are 3 data-bearing members of the replica set. You see the 2 green ones, those representing the visible primary and secondary that we offer. Then in yellow you have the hidden member. That member is what we take backups from. That way it doesn't impact the performance of your actual production database. Once a backup's taken, it's sent to storage and is available in the user interface so that you can download it or restore it to a new deployment. You can actually even access your backups through our API. At this time, Compose offers one single shard in MongoDB terminology that's known as the primary shard. At the moment, we're working on offering the ability to add shards so that you can shard your data. It's not quite ready yet, but it's getting pretty close. And when the time comes and when we do offer sharding in production, we're going to offer a lot more content to help get you started and choose sharding, like shard keys and all that stuff properly. Let's talk about MongoS failover a bit. So you see up top here these two MongoS nodes. Let's kill one of them off. Okay, so the right one has just failed for whatever reason. If your application was pointing to that one and only that one node, then unfortunately the application is now pretty much non-functioning. If you were pointing to the other one that didn't go down and only that other one, well, you'll be fine, but it's basically only by sheer luck. So you want to make sure that you understand how to implement high availability in your driver, whatever driver that may be, and specifically high availability when dealing with MongoS nodes. In MongoDB parlance, these are also referred to as Mongo routers because they route queries to the proper shards and proper primary members or secondary members of each shard. Now, as far as the MongoD, the actual replica set that's kind of abstracted away from the application, let's pretend one of those went down. Now, on the back end, behind the MongoS nodes, failover generally happens automatically. The MongoS routers are going to handle routing queries to the new primary, and your application should be okay. You generally want to bake in about 30 seconds of tolerance for queries kind of stalling a little bit, because that's the worst case scenario. It takes 30 seconds or so for a MongoD in the shard to that whole voting procedure to take place, a new primary to be elected, and the MongoS routers to properly route queries to the shard. Note that this is the same architecture regardless of if mmap v1 or WireTiger is used. Now that actually brings me to a good point, because there still are differences in storage and resource allocation between mmap v1 versus WireTiger, even though the architecture is identical. At Compose, all deployments auto-scale, but the ratio of disk to RAM is different between mmap v1 and WireTiger. And when I say that we auto-scale based on how much data you've put into the deployment. I'll show you some specific examples here in just a second. With mmap v1, we use a 10:1 ratio of disk to RAM. So we start you off at $31 for 1 gigabyte of pre-allocated space on disk, and that gives you 100 megabytes of RAM. So if you see 1 gig, 100 megs of RAM, that's the 10:1 ratio. After that, it's $18 for every additional gigabyte of space on disk, and you get an additional 100 megabytes of RAM. So as an example, 100 gigs of data on disk would get you 10 gigs of RAM, and it would cost roughly $1,800 US. With WireTiger, it's a little bit more resource intense, thus we work with a 4:1 ratio. We start you off with 4 gigabytes of pre-allocated space on disk and 1 gigabyte of RAM. That's $133 a month. There's the 4:1 ratio, 4 gigs of disk, 1 gig of RAM. After that initial start to your deployment, each additional gigabyte is $30, and you get 256 megs of additional RAM after that. As an example, if you have a 100 gigabyte deployment, you'll have 25 gigs of RAM, and it'll cost you roughly $3,000 US a month. So at this time, I'm going to guess that the deployment that we started a few minutes ago is ready for us. So let's go take a look at that. On the overview page of every brand new MongoDB deployment, there's this Getting Started with MongoDB section, and it has a lot of useful information. But I'm going to distill the Compose UI for MongoDB deployments down to what I think are the top 3 things that you should know about. First, you need to know how to create a database. So let's click the Browser section of the Compose UI. We call this the Data Browser, and it gives you the ability to browse your MongoDB databases, collections, and documents. To add a database, simply type into this box and then click Run. So let's create the next great mobile game. And then actually you can create a collection right away, so I'm gonna do that, a little bit of a bonus here. So you can't have a mobile game without high scores. Okay, so moving on to the second most important thing to know about the Compose user interface for MongoDB databases is how to create users on your database. I'm going to click back up to the deployment here to give this context. So there's our mobile game database, which is now an addition to the default admin database. Let's click back into the mobile game database. So we want to add a user. Let's click over here in the users section for the database. So notice we don't have any users on the database we just made. That's no good. We can't get working on the next great mobile game without a user on the database. So let's make a user. Let's call this, I don't know, front end. Awesome password here. You can create read-only users as well if you toggle this button. That might be useful for something like analytics tools or reporting tools, but we want to be able to read and write with this user, so we're going to create right now. Click in the Run button, and there's our front-end user. Okay, so just to refocus, we're going through the top 3 things that I think you should know about the Compose UI from MongoDB. We just covered the first 2, creating a database and then creating a user within that database. So let's move on to the third one. You should know how to acquire your connection strings. Having a database for our mobile game is really not going to do us any good unless we can get the application service connected to it. So what we're going to do is, now that we're clicked into the database, let me give you that greater context again. I'm going to click up into the deployment. There's our 2 existing databases. Let's go to the mobile game database. Within the mobile game database, or any database, you want to click this admin section on the left-hand side. Here we have 3 URIs that you need to know about for this database. The first one that you see right here, that first one combines the 2 MongoS nodes, as you can see. So recall that architecture slide we looked at, that there's 2 MongoS nodes that are your gateways into where your data is actually stored. Notice we have this one right here, which is the host name and port, and then we have a comma that separates the 2. Then we have the second host and port, and then it also specifies the database name. And since SSL is enabled on this deployment, we do have to give it, well, we don't have to in many cases, but it's often helpful to include that SSL option equals true. So this is if your driver or application can handle and parse multiple MongoS nodes in the same URI. That's not always the case. Now let's bring our eyes down here to this second set of connection strings right here. It's actually no different. It's not different hosts, it's not different ports, it's not a different database name. The only thing is we split them out. We take that comma out and we offer these just as a simple, very easy way of copying and pasting. Now if you remember back to the architecture slide, I did say that if one of those MongoS nodes was to fail, you would have to either hope that your driver can handle multiple MongoS nodes, and if it can't, then you're going to have to get creative and figure out some way of handling it. Here's how that rubber actually meets the road. Here's your 2 connection strings. You'd probably have to, in some cases, maybe worst case scenario, copy and paste the other node into your connection string in the application and the drivers, and then redeploy. But anyway, you'd want to check with your driver documentation and community to figure that out in specific. The third is the command that you would use to connect your deployment with the Mongo command line utility. And again, it just makes it easier for you to copy and paste into your terminal. Now that we have a database, a user, and we know our connection strings, we can now connect to the deployment. We can get data into it, we can query data out, and we can even get some stats out of it. Let's start by getting some data into this deployment. Now first and foremost, we can actually use the Compose UI to do this. You can click the Imports link on the left-hand side, and then you can click to create a new import. You have 2 options. You can import from a pre-existing Compose deployment and database, or you can import from a publicly accessible MongoDB deployment. So for example, you could import from another MongoDB hosted service provider, or if you are hosting your own MongoDB deployment, say on, I don't know, DigitalOcean or something, and it's publicly accessible, and you know the username and password and the URI, you can pull your data from there over into your Compose deployment. However, in this webinar, we're going to do all this importing at the command line. But before I do that, I actually need to create a super user, if you will, in the admin database. So let's click up into our deployment at large. If we go into the admin database, we'll be able to take a look at users that have control over the deployment as a whole. These are what you might consider root users or super users. Let's just create a super user, and we'll call it super user and a fantastic password. You're going to see the reason I had to do that here in just a few seconds. Basically, we're going to be using some tools that require super user or root access to the deployment to be able to see all sorts of fantastic stats. And those stats are going to come from the command line tool Mongostat. We're connecting up to our mobile game database with Mongostat. Some of the things that you can see with Mongostat are like in number of inserts and queries and queued reads, writes, faults. There's a lot of good stuff that you can learn from Mongostat about your deployment. So go head on over to MongoDB's documentation site and have a look at the documentation for Mongostat. Let's move to the second tab in my terminal here. What I have here is just a simple JSON file. It has all the works of Shakespeare in it. To do that, I'm going to use Mongo import, which will work on a JSON file. This is not specific to MongoDB. You can use any properly formed JSON file. And it's going to import into our deployment. Let's go take a look at Mongostat. Mongostat's getting busy over here. As you can see with all of the inserts that are happening right now, there's a little bit of faulting, there's some commands taking place, there's some network traffic going on in and out of there. Let's add more to the mix here. Let's do Mongo restore. Let's go over to my third tab here. So I have a 1.4 gigabyte BSON file. This was generated with Mongo dump, which creates a BSON file. This is going to be brought into our deployment using Mongo restore. And we're going to go take a look at Mongostat really quick. So now Mongostat is really heating up. We got all sorts of stuff going on here, a lot of network activity, a little bit more faulting, some inserts. So this is going to have a little bit of data now that we can play with. So let's go. Tell you what, how about we go to our middle tab here, and then the import is done, and I'm going to connect with the Mongo shell. Using the Mongo shell to connect to one of our Mongo S's, we are connected to our mobile game database. And I can show you all the collections. Look at that. We have our high scores collection that we created in the UI not too long ago. But now we have the Shakespeare collection, which we just used Mongo import to create. And we have the messages collection as well, which we are using Mongo restore to create. We can do a really quick little query here. Let's see what Shakespeare has to say. There we go. Let's do a little bit more. All right, let's jump over to the Compose UI and see what things look like now. And in the mobile game database, notice now we got some collections here to work with. We have messages and Shakespeare, just like we saw in the Mongo shell. I want to click back into Shakespeare. I'd rather read Shakespeare than in-run emails. Let's do a simple query. How about let's look here for everything that we can find about Macbeth. There's the results of our query. We got some documents, 10 documents, where the play name is Macbeth. That's a whirlwind tour of getting some data into your compose.io MongoDB deployment. Let's jump really quick back over to the slides. I'm going to wrap this up. Let's talk about connections and where you can find out some more information out about MongoDB. For example, today I was actually working with Ruby, and I connected to this very same test deployment right here. I had to install the MongoDB gem, and then we require Mongo, and we define a client object, connect up, as you can see there in the connection string. I used our front end user, and then the very last line puts collections. It just prints out the available collections within the database. If you're familiar with Node and JavaScript, it's pretty straightforward. And of course, you can connect with virtually anything these days. And for that and a whole lot more information, I would recommend that you go to help.compose.com. This is our help documentation site. There's a lot of great tutorials on how to connect to MongoDB here. And then also we have great articles, great content on our blog, compose.com/articles. And I hope you enjoyed this. I hope you got something good out of it. I'm going to turn this over right now.